All right, welcome. So so hopefully you enjoyed the Thanksgiving. Now I'm gonna record video the before Thanksgiving, but hopefully you enjoy. All right, so I'm gonna review for the quiz four. Okay, the quiz four for ENGR220 digital systems. Um, so I'm gonna just quickly go over for the quiz four. Okay, the question one. The operation SLH, yes, definitely, but with the control the input E. So this is not no more SLH with a NAND gate or a NOR gate. They have the two more the NAND gate. One, two, three, four. So this one is normally SLH with NAND gate. And then the SLH, the NAND gate, we learned before in the previous slides, not previous slides, in the lecture slides. And also we're going to learn before the book here, 251 page. Okay, the lecture, page 25. All right, so I'm going to skip Y derivation, but you have to know SR11 no change, 01 set 10 reset 00 is like invalid. Okay. So the EN0, we're gonna try EN0, 0 and 0. SR 0 or 1, it doesn't matter. Why? Because that was given to X. That means is X. That should be 1. 1. Why? Because the AND gate, the one of the input of the AND gate is 0. It's going to 0. But that was the ripple. Mean it's non-gate. It's like 1, 1. So the 1, 1 is what? No change. So this is why the no change. So how about the 1? Gonna removing here. There we go. So now from the 1, it was working 1 and 1, but still 0 and 0 is what? 0, 0, 1, 1. Same, no change. Okay. The next one. The other one is the EN is 1 and then S 0 or 1. 1, 1, not gate, it was the 0, and 0, 1, 0 is like 1. So 1, 0 is what? The reset. So that was the reset. And then third one, I'm gonna write there here. Oops, it's too much. And third one here, 1, 1, 0. Okay, 1, 1, 1, 0. I'm gonna just, oops, oops, sorry. Draw. Go. So the S1, the R0, the E at 1, 1, 1, 0, 1, 0. So 0, 1 is what? 1 set. So set state here. Now, the last one here, here. This is the 1, 1, 1. Right here. Just give me a second. Okay, S1, EN 1, 1, 1, 1, 1, 0, 1, 1, 0. So 0, 0 is what? Uh, the invalid. Okay, so this is the invalid. So again, so Q and Q prime is the final the outputs. So this is the two non-gate with the for the SLH. So it depends on the input from the previous with the enable that can be controlled and then get the output. Okay, so that is the answer for. All right, the second question. The second question is the logic diagram of a sequential circuit using two D flip-flop. Okay, this is one. and this is 2. Okay. So right there. And then the circuit has one input X right there. Here we go. And then one output. The output is right there. Okay. So carefully analyze circuit connection and complete the following test. So the question one, the D flip-flop, the input and output, the equations, and using the Boolean algebra, determine the input equation for both flip-flop and the output function A over t plus 1, B over t plus 1, and Y, and clearly show how each equation is obtained from logic diagram. So from the above, the logic diagram, I have to be A over t plus 1 is the equal to AX plus BX. Why? Because this is A, this is X, so this is the AND gate, the AX. This is X, B, the BX. And this is the sum logic. So I'm sorry, here, A over t plus 1 is AX plus BX. Okay, it's right there. So how about this one? B over t plus 1, B over t plus 1, right there. So this is the A prime. Why? Because connect to here, and X right there. So A prime dot X, this is the B over t plus 1. Okay, now the Y is definitely, this is the X prime. And then I'm gonna just remove it here. So in here, like this one, B, A. Okay, so A plus B. So now the AND gate A plus B, X prime is what? Again, Y do not have the time status. Output is just the output. Okay. All right. So that is for the answer for the A. All right. So the next one, we have to generate it, the state table for the sequential circuit with the two the two the the flip-flop for the question two. Um, let's say maybe as I said before, the two present state and one the inputs and 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, just until 1, 1, 1. So this is the A combination, okay? The 0 to 7, okay? 0 to 7. All right. So, and the next value, we have a lumpy for AX plus BX. For example, the first law, 0 times 0 plus 0 times 0, 0. Okay. How about the B? The A prime. So 1 dot X. What is the X? 0. It's 0. So this is Y is 0. And the Y is definitely 0 plus the 0. And X prime, I'm sorry, the 0 prime is the 1. So 1 dot 0 is 0. So this is Y 0. It's like the same pattern, the other one. Okay. You can practice here. All right. And C. C is the reduced form, or sometimes called as second form of the state table. What does that mean? So we can try to new format. I'm gonna just write draw here. So the output X is equal to 0, 1. Next state X is equal to 0, 1, the present state. So the present state is like the 2-bit 0, 0, 0, 1, 1, 0, 1, 1. And the next state, I'm gonna drawing for you right there. Just give me a second. Here we go. The boolean. All right, so X is equal to 0. That's right there. So the present state is 0, 0, 2. Next state, 0, 0. Okay, so this is y 0 and 0. Now, sorry, the present state 0, 1, for example, in here, but the x is equal to 0, and next state is what? 0, 0. Now the next one, 1, 0, the x is 0, next state is what? 0, 0. Same thing. 1, 1, when x is equal to 0, next state, 0, 0. Okay, same thing. The 0, 0, the x is equal to 1. The next state is what? 0, 1. Okay. And then the same thing, 0, 1. So next, the output, just give me a second. 0, 1. The x is 1. The next state is what? The 1, 1. So on. Okay. So the y is like the same thing. For example, the present state, the 0, 0, for example, in here, and what and the y x is equal to 0. The y is what? 0. Okay, it's kind of this one. So if you just tracking and follow up the condition for x and y, it's like from the present state to the next state, you can just find it. That is not require complex the equation. So second. So oops. So maybe after you found the reduced form we learned before in the lecture and the books, you can draw state diagrams. The several students has a lot of mistake in here. Let's just write that. Give me a second. State diagram, it should be showing the state. So for example, I'm gonna show you the more bigger one. 0, 0 to 0, 0 when the x is equal to 0 and x is equal to 0, y is what? And 0, 0. So 0, 0 and to the 0, 0, the next state, x 0 and y is 0. Okay. So that is for x, oops, the x and y. Here we go. And for example, 0, 0, 2, 0, 0, 2, 0, 1. When x is equal to 1. 0, 0, 2, 0, 1. Right there. So x is equal to 1 and y is what? Right there. 0. Something like this. Okay. So you can practice to find the state diagram from the reduced form from the between the two states. It depends on x and y value. All right. Oops. All right. Any questions? All right. So the question three. So question three, from the figure, that is the homework question. Okay. This is the homework, the same question. So derive the state table and the state diagram of the sequential circuit as shown in figure P5.8. Explain the function that the circuit the performs. Okay. So here we go. Now, oops. Now, this is the T sub A, okay? And this is T sub B. This is the OR gate, right? And two inputs. One is what? A. The other one is B. So the T sub A is A plus B. So how about this one? The A prime, the plus, and B. Okay. So the present state is 2-bit 0, 0, 0, 1, 1, 0, 1, 1. And T sub A, the A plus B, 0, 1, 1, 1. because 1 plus 1 is 1 in the Boolean algebra. If you're still being confused, please go to back to chapter 1 and 2, and then strongly recommend you're gonna review again. Okay. And then Tisa B is the A prime 1 and B is like 0. B is 1. And second one is the A prime 1 plus B is 1. The is what? That was 1 here. Okay, 1 plus 1. 1. So how about this one? Uh, that one, 0 plus 0 is 0. How about this one? 0 plus 1, because the A prime is the 0. Something like this, okay? And the next state, you know, so what is the next state? Thinking about what is the next state? Okay, so I strongly recommend you have to keep in mind in here, the T flip-flop is 0, no change. 1 is the toggle. Okay. 0 is no change. 1 is the toggle. 0 is the no change. Right? Disobey. No change. 0. 1 is the toggle. 1 is the toggle. 0 to 1. 1 is the toggle. 1 to 0. So on. Okay. So you can the fill out this one. And then after that, so you can do the draw the state diagram, because from the question you have to draw a state diagram. Means the present state, the next state. But again, this is not the output, just only the input, two input, T, A, and B. So for example, 0, 0 to 0, 1. So TA, the TB, just 0, 1. Okay, because no the output. So just we're gonna to using the 0, 1. So the input state, next state, present state, you can figure out, and also state diagram. Okay, it's very important question. All right, so the several students has mistake in here. The question 4. So just give me a second. Let me just let the draw here. All right, the last questions. Um, Here we go. So this is the state table, but we wanted to state reduction. Okay, state reduction from this table. So first of all, I'm gonna just skip the maybe A. Okay, so you can draw yourself. The second one, that was identify any equivalent circuit, reduce the state table by the state reduction. So as we learned before, I'm gonna explain for you step by step here. All right. So I'm gonna be moving now. So oops. So AF01. So AF01 is same. So now we're gonna try to reduce states. Okay, states. So means G is the same. G is equal to E. So now we wanted to draw and removing the last one. So means we have to try G is E. Now, so the after we're gonna moving from G to E, here and here is the same. Means D is equal to F. So now we're gonna just removing here, and then all the F should be the D. So now I'm gonna make it more clear. Let's say in here, off and off. So now they have only to AB there. So A, B, C, D, E, A, C, A, E, A, D, 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 0, 0, 0, 0, 0, 0, 0, 0, 1, 1. Okay. So that is for the reduce the state table by using state reduction here. And then in here, so for example, A to A, for example, the A to A, that was the input X is equal to 0. The output is what? 0, something like this. And also the A to B, for example, X is equal to 1, it's right there. And then it was the 0, something like this. Right? So finally, you can draw the state diagram from the reduce the stable from the B. That is the answer for. Okay. So maybe honestly, I strongly recommend you want to practice on yourself. That is really helpful. We have a lot of the homework questions as well in here from the lecture. Okay. All right. Thank you. Bye.